after this page, I'm going to have to go through how you do these, because these take a little bit more effort. And also use some formulas you're not used to working through. Okay, so I need to explain what's going on here. All right, so you'll need to concentrate on this. Students find this generally quite difficult, although it really isn't. It's just a matter of following steps through to get there. But unless you concentrate on it, you really have the potential to struggle with it. So I'm just going to, these questions are the starter projectile questions. And they make it relatively easy by making one of the components, either the horizontal or the vertical component of motion, 0 to start with. So a lot of the questions are just like dropping something or kicking it off the edge of a cliff. And that takes out one set of calculations you have to make. So let's look at this first one. A lifeboat is dropped from a plane moving at 140 metres per second from a height of 1140. Let's see what it is. 1102.5 metres, right? So when you have a question like that, what's the first thing you're going to do with it? The question are these ones, the initial velocity. So they give you a situation, you ask to find the initial velocity, its initial horizontal, initial vertical, its range, its horizontal. Right, well, I'll have to go through each thing to show you. So the first thing you always do with something like that is, one, find the pen, and second is to actually draw what you're doing. I'll do that on the board in black. Now, it doesn't have to be a great drawing, it just represents what you've got going on there. So you've got a plane, which I, just like that. It's travelling at a certain speed, which is 140 metres that way. So it's like that. Oh, thank you. And what will happen is this lifeboat will go in a curve down there like that of some sort till it hits the ocean beneath. And that initial drop is from a height of 1102.5 metres. That's the path the lifeboat will travel down.
The curve being in the opposite direction?
Like that.
No. Like mirror that. You're dropping it from a lifeboat, so it's going to go back.
No, a lifeboat's dropped from a plane, so the plane's travelling that way, and it will travel with the plane and fall. So that's the shape of the path it will take.
Yeah, because I'm thinking from the point of perspective from the plane.
Yeah, so this is us standing out on a headland looking at it happening. So the data that I do have, I can write in. And there's some things they don't tell you that you need to put into your data. So the first thing that you know is that its initial speed, u, is 140 metres per second. But it's not got any angle. The angle's 0 because it's going straight out, isn't it? Because it's dropped with the plane. Okay. And then what I'm going to do is I have an acceleration. What is accelerating it? Due to gravity. Now, so that's g, and I can nominate that as either the positive direction or the negative direction. It's up to me. In this case, because it's only going that way, because it's only falling downwards, I'm just going to call it 9.8 metres per second squared. Okay, and I know that it's going to fall a vertical distance, which I'm going to call delta y, which is the standard way we talk about it, a vertical distance of 1102.5 metres. Now, what you may not know, that's interesting, I want to get another one of these little windows going. There's a series of formulas you can use to solve any of these problems. I'm not going to tell you where they come from, I'm just going to write them up. One you do know pretty easily is V equals U plus AT. So the final velocity equals the initial velocity plus acceleration times time. Okay? We used that a lot in the last, you might recognise it as this. A equals V minus U on T. Another formula which has to do with this is V squared equals u squared plus 2a delta, and I'll call it y in this case. It can also be horizontal, doesn't really matter. And there's also delta y equals ut plus a half at squared. Right, they're the three main formulas that we use for solving these sort of problems. And you need to know those and just be able to pick them up and use them. All right. So the first thing you'll know is the initial velocity of the life raft that's falling, don't we? Okay. Now for this case, the initial velocity is really very easy, because let's get that out of the road. And I don't want that. I'm pretty excited by being able to do that. It's pretty neat. Okay, so the initial velocity, question A. What was its starting velocity? 140, I'll just read that off. V equals 140 metres per second minus 1. And it is, what's its direction? Because the velocity has direction, so it's horizontal. That will do that one. 2, hard to see, isn't it? B, its initial horizontal velocity. So that's ux. Why would it be a different answer?
Well, you've just written for A that 140 metres horizontal.
Yes.
So like, I don't know.
Oh, how much of that motion is sideways? All of it.
Yeah, I know it's the same answer. I'm not questioning that. I'm just questioning that. Like,
that's just C. Its initial vertical velocity. That's easy. Uy equals 0, because it's initially not falling, is it? In the first millionth of a second, it's not actually falling, or probably billionth of a second, depending on how sensitive instruments are. Because it's started going sideways, there's no vertical component to it, so that's pretty easy. Now the range is the more difficult one. This is where we start having troubles. Okay, so I have a couple of formula which I've just whizzed off there, which are hard to read. I probably need to bring them back. Yeah. And what you can see is that has time in it. This one here, which has disappeared behind that, I've got the distance travelled equals ut plus half at squared. It has time in it, right? This one, v squared equals u squared plus 2 ay. I could find out the distance travelled, couldn't I, without involving time. But it's a little bit more subtle than that. So when you do these questions, what you need to do is you need to look at what you do know and look at which formula you can plug the numbers in and get one thing left, and that will be you rearrange the equation and solve it for that. So if I wanted to look at this one, and I thought, oh yes, I can put my vertical speed in it, sorry, my horizontal speed in it, and my starting horizontal speed, and 2a delta y. The problem with that, doing that, is quite simple. Let's try it. So I'm going to, I say, I can use this formula, vx squared equals ux squared plus 2ax delta x, right? That's the formula. So use the initial velocity.
So that one there was just data, that's really used.
It was written as, which one that?
Yeah.
Well, that was v. That was the initial velocity, which also happens to be its u. Oh, I see what you're saying. Yeah, I should write as u. So when I put this in, okay, ux, what is it? It's 140 squared. Now, what do we know about the speed going sideways? Does it change? So that's 140 squared. What's the acceleration sideways?
0.
0. 2 times the 0 times delta x. So that means that part of the equation there disappears. And all I find out is 140 squared equals 140 squared, and everyone goes, oh darn, that doesn't work. And then what you do,
So why does the velocity,
because there's no horizontal acceleration, there's nothing, there's no force acting sideways on it.
but if you say it slows down, it slows down that.
That doesn't slow down. I mean, we're pretending air doesn't exist,
Yeah.
but the fact for our course is that ignoring air resistance, and if you're doing this for air force drops and things, you have to put another calculation into it. It just keeps travelling at the same speed that way. Remember, Galileo said that way and that way are independent. So the horizontal is independent of the vertical motion. There's no force on the horizontal, so it just keeps travelling along at 140 because gravity is pulling it down.
So it's 140, 140, 140, 140.
Only the horizontal part of it.
Yeah.
The vertical part is increasing in speed. So at this point, sorry guys, beside, at this point here, it's purely going 140 kilometres an hour, metres per second that way. At this point here, it is travelling at 140 that way, but it's also travelling with a certain speed that way, so the resultant is that bit. It actually increases its total velocity. Right, so a lot of students would do this in the exam. I've done it myself early on and go, that makes sense, but I haven't got an answer, and they give up.
So how doesn't it make sense?
But that doesn't help you find out its range, which is how far it travelled sideways.
So you use the change from y.
So
What is range? Can you really explain what the range is?
the range is how far it travels from that point. Whoa, let's put that back. It's how far it travels from where it starts to where it finishes in a horizontal direction, right?
So if a plane started at Sydney Airport and finished at Los Angeles, the range would be so and so kilometres.
Yeah, that's right. So in this case, what determines its range? Well, the first thing that you do know is that Vx, its speed, equals the distance travelled over the time taken, doesn't it? So the distance travelled in the x direction must equal its speed times time. Now, we don't have time, so we need to get it from somewhere. How are we going to find that out? Well, we know that this object has fallen from that height down to there. It's fallen 1102.5 metres, hasn't it? And so it started at 0 and it's been accelerated by gravity until it's fallen that distance. So now I can work that out, because watch this. If I use this formula, I'll do it in green on this part of the board. Now I'll look at this particular formula here. Again, v squared, but I'm going to make it y equals, no, is that the formula I want? That's not the formula I want, sorry. It's this formula I want. I'll write it up now. So delta y equals uyt plus a half ayt squared. Now, let's think about this. Do I know delta y? Yes, I do. Do I know uy? Yes, I do. It's 0. So that bit comes out. Do I know ay? Yes, I do. And that's the thing I want to find out. Yes? Acceleration due to gravity. So what I can now say is that 1102.5 equals, well, that's 0 times time, so that bit just doesn't go in there, because you know that 0 times anything is 0, plus 1/2 times 9.8 metres per second squared times t squared. Therefore, t is going to equal the square root of 2 times 1102.5 all over 9.8. And that'll give me the time. That's a half. So I've had to, because that's 2 on the bottom of that side, I put it over there on the top. That's that multiplying through. 15 seconds. So it takes 15 seconds. Yep.
Where'd you get the square root?
T squared.
Like, is it absolute value or should it be plus
No.
or minus?
No, that's what it is. It's t squared, so it just becomes a
so
square.
when you do the square root to the other side, it should be plus or minus that number.
You can't have minus time.
So it's absolute value.
Yes. We can theoretically have minus time, but that would mean that things travelling upwards or things, you're going backwards in history or something. So we kind of ignore that. Okay, so it's taken 15 seconds now. We've worked out time. It takes 15 seconds to go from the aircraft to the ground. Now, because we know it took 15 seconds, and we know the distance x, or the range, equals vxt, that just simply becomes 140 metres per second times 15 seconds. And that will tell us how far it went in the horizontal direction in the time it took to fall that distance.
How many of these type of questions are there going to be on that?
Normally there's at least one, sometimes there's up to 3.
But, like, I mean, these type of questions is in, where you've got to do a lot of calculations to that sort of...
Sometimes up to 3 or 4.
Oh, only 3.
3 or 4 of...
Of those,
How many
of
questions are there this year?
Oh, it varies year by year.
I don't absolutely like that before.
No, you're looking, you got your 20 multiple choice, and then normally there's something up to about another 18 short response. Then you have your option topic to do. So there's a bit to do. So if I multiply that out, that's going to be what, 1400 plus 700, so it's 2100 metres. Now, so everyone get that? No. It takes practice. It does. I know. I can see people going, that's a bit hard. But that's why we have lots of questions to do here.
So, for our option topic, would we be able to pick out of medical science and astrophysics? Does anyone want to do geophysics here? Like, I just think...
I like geophysics.
Those two of them.
Yep.
That data there we got reviewed, is that UX?
Yes. Yes.
No, just down here.
Oh, there. That U. That's the starting speed. So the whole. It happens to be UX, but it's only UX because the initial speed was all in the horizontal. Now these are simpler questions. Let me emphasise that these are simpler questions. Let me get rid of some of this stuff, because you'll learn it by doing it. That's what you have to do. So I don't want to scare you with this, but this is starting level. What they have done in the past for questions is giving you a situation, for example, where you have a cliff with a cannon on it, and then there's another cliff with a castle on it. This is actually an HSC, and there's a window in the castle. And you fire a cannon so that the ball goes through the window. And they give you a bit of information, but you have to work out what angle the cannon was fired at to make the ball go through the window. So you have to become a bit proficient at doing these sort of questions. Okay? You can. But you can also use these methods. All right, let me do one more in a more organised way on the board for you, just to take you through how to do it. Okay, let's look at number 2 here. And I know people's heads are spinning and they're saying this is all too hard, but honestly, the majority of this stuff is just going step by step by step by step and plugging numbers in the formula. And honestly, they always give you enough information to be able to answer the question. So if you plug numbers in a formula and it doesn't work, it just means you need to use another formula. And there's a couple of tricks they use. Tom? Oh, sorry. Okay. I've rubbed all my work out now. Yeah. With its final horizontal velocity, that's easy. Because as I said, it's not accelerated horizontally. So its horizontal speed must be 140. Its vertical velocity, that's not too bad now. Vy equals uy plus ayt. Now we know that we want to find Vy, we know uy, we know ay, and we know t. So we just put the numbers in. Uy was 0 plus, yes, 9.8 times 15, and that ignoring air resistance yet. So if you put that in there, what's that going to be? Anyone want to work that one out for me?
Roughly 100.
Yeah, very, very roughly 150.
9.8.
What's 1/4?
47.
So that's the final vertical velocity. Now, do they ask you in here? That's it, isn't it? Oh no, it's final velocity. Okay. For final velocity, funny enough, it is. Because what you, hang on. So what you've got is you've got 140 meters per second of the horizontal velocity, haven't you? And you've got a vertical velocity of 147 meters per second. And so your resultant is your final velocity, which is going to be that there. R. So R, as was quite rightly put, was 140 squared plus 147 squared. That will give you the size, but it doesn't give you one other thing that you need. What else might you need to know? You need to know, there's the ground, you need to know the angle to the ground. Because it's a vector, size, direction.
I just say
Down?
size, yeah, no, southeast.
Well, no, that's up and down. It's not a compass direction. It's fallen from a plane. Southeast is over there somewhere.
Labelled north on your paddock.
Well, yeah, what you actually do, that angle there must be that angle there, mustn't it?
I'll say it's 90 parallel.
Well, given that must be parallel.
Yeah.
Right, okay. So I want to know that angle in there. So the inverse tan of
Escape regions in that sense.
will equal theta. And then what you can say, of course, is that it hits the ground at an angle of 32 to the horizontal. That gives you the answer.
Well,
That's why they're giving you trouble, Tom. It's all these little steps you have to do.
Are those the questions that take up the majority of their time? Or is it like...
Students typically hate, I shouldn't say it, but they do typically hate these particular type of questions, and so they tend to be slow at them. It's just methodical. One of my friends labelled this wombat work. You just wander your way very slowly, methodically through the whole thing.
I got 46 degrees, 23 minutes. Oh, sorry, 24 minutes.
To the horizontal.
Well, I just put in...
Yeah, well that's what it is, it's
I
that.
just put in the inverse tan of 147 over 40.
Yeah, so that's what it is, 140, whatever. Now the thing is, there's only the 4 formulas, and you just got to use those 4 formulas, information you have, plug the information in order to get the stuff out that you need. You just need to work out which form you need, where you put your numbers, and plug in your calculator. Another famous physics fellow named this plug and chug questions, because you pick your formula, put your numbers in it, chug it through your calculator, get something out the other side.
Is that those formulas?
That's them, yeah.
It's 5, though. Yeah, it's 5.
What one of them's Vx equals Ux, isn't it?
Yeah. Vx squared equals Ux.
Yes, which as I just showed you is a special case of Vx squared equals Ux squared plus a half AT. Sorry, whatever it was. Okay, what's my machine trying to do here? Why is it spinning its wheels? Okay, let's have another look at another one just to get you through so you're going, I hate this. But anyway, we'll do it again.
What would you get? Right.
For the angle.
Let's do something a little bit more difficult.
46 degrees, 24 minutes.
I'll put 147 balls at
Just graph that 147 over 140.
Yep.
Because I found the it was 207 was 203 was the was that was the what this
I thought these.
That's 240, so you can actually want sine 147 and 203.
You can do it that way.
But I got 0 degrees.
Well, that means one answer's wrong, and I didn't put it in my calculator to work out which one it is. One of you is wrong.
I did sine 100
They said.
It has to be inverse sine of.
Why does have so many big red buttons everywhere?
They're emergency cut-offs. Okay, let's look at question 3. I'll take you through it. I hope I have time to get through it.
Yeah, so what?
No, I don't have 2 minutes. 7 minutes. Because
Trying to work out the angle.
sine theta will equal the... that's one way of putting it, I suppose. Okay, let's look at question 3 here. I'm going to quickly put in my data. A ball is thrown horizontally from the top of a building. So you've got some sort of building like this. You get a ball which you throw from it. It's going to do this. Sort of, kind of. It lands 50 metres in front of the building. And it took 3 seconds to get there. So the time to fall was 3 seconds, wasn't it? Okay. And that's all we're told. So what I'll now do is I'll put my data in. I know, now, this is a bit different. Do I know my initial speed? U equals question mark. Question 3. So I don't know anything about its speed. Uh-oh. Now we're in trouble. Okay, what do I know? I know that delta x equals 50 metres. I know I have a time, which is 3 seconds. And I know I have an acceleration of 9.8 metres per second squared. This is where I have to start using some logic. Now, I can't do it in the order they asked me to work it out in, I don't think. But let's see what I can manage. First thing I work out. Let's put that up there and I'll expand it down so I have a working area. I don't have much to work with, do I? So, if I want to find a speed, let's start with the horizontal one. What do I need to know to find out my speed? What are the 2 things I need to know? Distance and time, isn't it? Is that right? So I need to know a distance and a time. Do I have a distance and a time? So I know I went 50 metres in 3 seconds. So I now have a speed, which will be 16.6, I think. Now, interestingly, because it's been thrown horizontally out, is that also my starting speed? That's my UX. What do we know about UX? It doesn't change, right? And it's thrown horizontally off the building. So my initial speed, which is question 1, U, equals UX, which equals 16.67 metres a second minus 1. Then I was asked to work out what my question 2 was to find UX, which I've already done, see above. Question 3 was to find UY, because it's thrown out horizontally, it is
So, just,
Yeah.
how again is U equal UX?
because in this case only, it was thrown directly off the building. You can imagine someone getting a bowling ball and bowling it, so its initial thing is horizontal.
We can go do that. That would be so much.
So, and, so what is U in this case? I'm just confused.
U is the starting speed.
Starting speed.
It just happens to be the same as UX because it started going horizontally.
But if you threw it like that, then U would...
Then I have other calculations to do, yeah. That will be 0 because it went sideways first up. There's nothing up and downwards.
Yeah.
Yep. What else must I find? Oh, the height of fall. So what's delta Y?
8.3.
Well, we had some formulas, remember? Delta Y equals, gone straight in my head. Delta Y equals, oh yeah. Sometimes things just drop out of my head. It's because I've got that formula. This makes it really easy. Because I know that that bit there is 0. It doesn't exist. So that's a half times 9.8 times 3 squared, which is going to equal whatever you get in your calculator.
9 times 9.8. It's going to be like 37, I guess.
I should have my own calculator out and do it.
41.
Oh no, I didn't swear.
40 what?
44.
44.1. So that building is a 44 metre tall building. It's not a bad sized building, is it? What's the range? Well, the range is from there to there. They told us the range, so delta x is the range is 50 metres. And then we had to find out, if you remember, we had to find out its final horizontal speed. Well, that just happens to be the same as the starting horizontal speed because there's no force.
Symbol for range, 4x.
Delta
Oh, delta.
x. Now, for the next part we had to find out was Vy, its final vertical speed. Now, Vy, as you remember, is Uy plus At, which is just going to be 0 plus 9.8 times 3, which equals 29.4 metres a second minus 1. So then to find the final speed all up,
So how is the Vx 16.7?
because
It doesn't change.
it doesn't change. That's right. So there you go, guys. That's the start of doing this stuff. And sorry it's a bit scary.